So let's see, this time we will talk about all these, what we can say, this was exactly the next to the, uh, let me start, just, this is a topic that was after the
Okay.
alkyl halides. So this is amines. So this is exactly the topic of your book. That is immediately after that. So we will talk about all these. These are once again the organic compounds. Now, if you can read, please.
Amines
Yeah.
are carbon, hydrogen, nitrogen compounds. Amines
Yes.
occurs widely in living organisms. Many amines are naturally occurring compounds that are very active psychologically,
Physiologically,
physiologically. Numerous drugs used for the treatment of mental illness, hay fever, heart problems, and other physical disorders are amines.
so this is the basic, what we can say, the brief introduction of amines. Amines are carbon, hydrogen, and nitrogen. So these are the three elements which are composing together to make the new type of the compound, which is called amine. Amines occur widely in living organism. So naturally they are present in living organism. Many amines are naturally occurring compounds that are very active physiologically. So it's these are the natural, and as these are coming out from the physiologically active compounds, so definitely there is a active role in our life. Numerous
Yes.
drugs used for the treatment of mental illness, heavy fever, heart problems, and other physical disorders are amines. So these drugs are used with these critical diseases in the human nature, human body. So let's see what is the next. Yes, if you can read this. Bonding. Hello. Hello.
I can hear you.
Yes, yes.
Bonding
So,
characteristics of nitrogen atoms in organic compounds.
yes.
An understanding of the bonding characteristics of nitrogen atom is a heuristic, heuristic
Prerequisites. Prerequisites
prerequisite to
to
our
our.
study of amines. Nitrogen is a member of group of the periodic table. It has 5 valence electrons and it will form 3 covalent bonds to complete its octet of electrons.
Yes. So it's a very simple. Nitrogen is a member of group fifth A, fifth A of the
Yes.
periodic table. So as to understand the bonding characteristics of the nitrogen, so atom is nitrogen atom is the prerequisite to our study of amines. So it has 5 valence electron and it will form 3 covalent bonds to complete its octet of electrons. So what I mean to say that these are the 5 of what we can say the valence electron. Valence electron are those which are revolving in the outermost shell of an atom. So these can be adjusted to anywhere to make the covalent bond. So definitely the 3 covalent bond can be formed very easily. So here one can be combined because covalent bond is actually the presence of the pair of 2 electrons. So on this side, on one side, these are the 2. So there is no space for any bonding. So here we have one less and one less, and finally one less over here. So on these two sides, that's why the 3 covalent bond can be completed from the electrons of the nitrogen. So this is a way to form the single covalent bond because these are the single lines. So let's see what is the next. So If you can read,
In
please.
organic chemistry, carbon forms 4 bonds, 4 valence electron, 4 covalent bond, no non-bonding electron pair. Nitrogen forms 3 bonds, 5 valence electrons, 3 covalent bonds, 1 non-bonding electron pair. And oxygen forms 2 bonds, 6 valence electron, 2 covalent bond, and 2 non-bonding electron pair.
So that's why what we can say, these are the basic, the carbon, nitrogen, and oxygen. So when they are coming together, so we will definitely get the amines, one of the amines compound. So carbon 4 valence electron, 4 covalent bond. So the carbon is surrounded by 4 side, only the one valence electron. That's why all around its 4 sides, the 4 covalent bond can be what we can say constructed, can be made. No non-bonding electron is not there because it has 6. So 2 is in the first innermost shell, and other 4 are revolving around as a valence electron. So they can make the 4 covalent bond. Nitrogen forms 3 bonds as we have seen in the previous slide. Oxygen forms 2 bonds. So definitely only two sides are open, 2 to 4, 5, 6, and these are in the outermost, and in the innermost there are 2 electron, 2p, 2s, the subshell of the first, what we can say, the innermost shell. So that's why 6 valence electron, 2 covalent bond, and 2 non-bonding electron pair. So these are the, what we can say, the atomic configuration of the basic elements of amines. Next, structure.
Classification. An
Yes,
amine is an organic derivative of ammonia in which one or more alkyl, cycloalkyl, or alkyl groups are attached to the nitrogen atom. A- Amines are classified as primary, secondary, tertiary on the basis of how many hydrocarbon groups are bonded to the ammonia-nitrogen atom.
yes. So basically, their structure is just like NH4. NH3 is the ammonia. So ammonia is this is the organic derivative of the compound. So amines are classified. So it's this the same classification is also written in your book. So primary, secondary, and tertiary on the basis of how many hydrocarbon groups are bonded to ammonia nitrogen item. Next is primary. First type is,
Primary is an amine in which nitrogen atom is bonded to one hydrocarbon group and two hydrogen
hydrogen
atoms.
atom. Yes,
The, gen- the
the
generalized formula for a
generalized.
primary amine is RNA2. The
So
functional group,
functional group, N is inside, and here we can say the 2 hydrogen, and third one is any compound of that nature. The functional group present in a primary amine, the NH2 group is called amino group. And amino group is the NH2 functional group. So once again, the formation, this is called the structural formula, and this is called the chemical formula. So whatsoever the third element is there over here for R, so that can be connected with any other the carbon or whatsoever the hydrogen is there. So that type of called the primary amine. Next is
secondary, is an amine in
yes,
which nitrogen atom is bonded to two hydrocarbon groups and one hydrocarbon atom. The generalized formula for secondary amine is R2NH.
yes. Also here we can see the R2 and H is 1. So this is the chemical formula. Once again, the single line is showing the bonding, the single covalent bond between all these atoms. Yes, the next one is
Tertiary is an amine in which nitrogen atom is bonded to three hydrocarbon groups and no hydrogen atom. Generalized formula for tertiary amine is R3N.
so that's why the three R's are available. So that's why
Yes.
this is combining with the N. So this is the structure form. And here we can see the exact form of the bonding and the amine. Next,
Classify amines. Each of the following amines is primary, secondary, or tertiary. This is a secondary amine because the nitrogen is bonded to both a methyl and phenyl group. Here we have tertiary amine because the nitrogen atom is bonded to three methyl groups.
methyl group. So these are the, what we can say, the examples, and many more examples are also written in your book. So these are just only
Yes.
for the example that how can we differentiate between secondary and tertiary and the primary amines. Next is, this is also,
This is also a tertiary amine. The nitrogen atom is bonded to two phenyl and a methyl group. This is the primary amine. The nitrogen atom is bonded to only one carbon atom.
so only one carbon and two and three and furthermore. So these are basically classified with the carbon because carbon hydrogen are the basic element of the all organic compounds. Now let's see. These are once again a few examples. So first one is for the primary, the second is
Yes,
also for the primary, and the next is secondary, and the last one is tertiary amines,
yes,
the final type of this. So once again, this is the another combination. The open ends, what they are describing, that they can be adjusted with any of the elements. So all these lines can be filled up accordingly when there are the carbon or the other atoms are connected with these.
why?
Physical properties. Physical properties.
Physical properties. The methylamines and ethylamine are gases at room temperature and have ammonia-like odors.
Yes.
Most other
So
amines
ammonia
exist,
like
but many
odor.
have odor
Yes. Next.
resembling that of raw fish. A few
Yes.
amines, particularly diamines, have strong disagreeable odors. The foul odor arising from dead fish and decaying flesh is due to amines released by a bacterial decomposition of protein.
So these are the physical properties. The methylamines, monodiode, and ethylamines are gases at room temperature and have ammonia-like odor. Then most other amines are liquid, and many have odor resembling that of raw fish. So very unpleasant. The next is a few amines, particularly diamines, have
Have
strong
strong.
disagreeable odors. So unbearable. The next is the foul odor
Foul.
arising from dead fish and decaying flesh is due to amines released by the bacterial decomposition of proteins. So when the deads are there, so the first process is decomposition of the proteins inside the body, and that time these amines are very active in the nature. Next is dia.
Diamines,
Yes.
putrescine, and tavarine are two odoriferous compounds. The simple amines are irritating to the eye, skin, and mucosa membranes and are toxic by ingestion.
Yes.
Aromatic amines are generally toxic. Many amines are readily absorbed through the skin and affect both the blood and the nervous system.
And nervous system. So these all are the what we can say the physical properties of these. Next, the boiling points.
The boiling points of amines are intermediate between those of alkanes and alcohols of similar molecular mass. Amines are higher than alkaline boiling points because hydrogen bonding is possible between amine molecules but not between alkane molecules. Intermolecular hydrogen bonding of amines involves the hydrogen atoms and nitrogen atoms of the amino groups.
So all these boiling points and their formations, these are all of what we can say the structure. So these are the physical properties included in the physical properties. Next,
Terrestrial amines have lower boiling points than primary and secondary amines because intermolecular hydrogen bonding is not possible in terrestrial amines. Secondary and terrestrial amines have no hydrogen atoms directly bonded to the nitrogen atom.
So these are the what we can say the comparison of the boiling point of these different type of the amines. Next, the boiling.
The boiling point of amines are lower than those of corresponding alcohols because nitrogen-hydrogen bonds are weaker than oxygen-hydrogen bonds. Note the difference in hydrogen bond strength results from electronegativity between nitrogen is less electronegative than oxygen.
So few examples are just like that. That electronegativity values nitrogen 3, hydrogen 2.1, oxygen 8.5, 3.5, and next one is 2.1. So difference is this one. So that's why these are showing the different difference of the boiling points. Next,
Amines with fewer than 6 carbon atoms are infinitely soluble in water. This solubility results from hydrogen bonding between amines and water. Even terrestrial amines are water soluble because the amine nitrogen atom has a non-bonding electron pair that can form a hydrogen bond with hydrogen atom as well.
so solubility is once again what we can say that is the physical property. So here this slide is clearly showing then these are soluble in water in the normal condition. Next,
Basicity of amines. Amines like ammonia are weak bases. Ammonia's weak base behavior results from its accepting a proton from water to produce ammonium ion and hydroxyl ion.
so this is all about that we have seen that the basic and the acidic nature of the different hydrocarbons atoms. So that's why this is the alkaline in nature because it is getting the proton hydrogen ion, positive ion. So this is one of the theory of the classification of acids and the bases. Next,
Amines like ammonia have a pair of unshared electrons with the nitrogen atom present. These
these
unshared atoms can accept a hydrogen ion from water. Thus, both
water.
amines and amino produce basic aqueous solution.
Yes. So what we can say that's why these are the soluble in water because they have by built the acceptability of the hydrogen ions and mixing with the water. So their structural bonding or the structural formula helps to make the bonding between the water and these amines. That's why these are soluble all the time in water. Next,
The result of interaction of an amine with water is a basic solution containing substituted amino ions and hydroxyl ions. A substituted ammonium ion is an ammonium ion in which one or more alkyl cycloalkyl aryl groups have been substituted for hydrogen atoms. Substituted ammonium ions always contain one or more hydrogen atoms than their parent amine. They also always share a +1 charge, where the parent amine is a neutral molecule.
so this is all about the chemistry or the chemical nature of the solvent reaction with the waters, production of the ions, and then these are getting the positive hydrogen ions. So that's why they are getting the positivity over there when they are interacting with the liquid, that's especially water. Next,
Naming the positive ion that results from the interaction of an amine with water is based on the following two rules. For alkylamine, the ending of the name of the amine is changed from amine to ammonium ion. Ethylamine from ethylammonium ion.
yes.
Ethyldimethylamine from ammonium ion.
So all these chemical reactions are just shifting of the ions and reproduction of the negative hydroxide ions. So that's why they are just changing the name because the presence of the ions. So that's why ammonium ions. These are just the nomenclature due to the change in the ionization of these compounds, especially with the action of water over there. Rule 2.
For aromatic amines, the final electron of the name of the amine is replaced by ion.
So aniline, alanylium oil, methane, methylenium oil. So this is all about that because the negative electron is moving over there and they are just leaving the positive nature of the compound. So that's why IUM point is increased. So aniline, alanilinium, methylene, methylenium. So these are the nomenclature due to the presence of E negative charge. Name the following substitute ammonium.
Names of the following substituting amines are substituted aluminum,
So
diethylammonium
uh,
ion,
yes,
trimethanium.
the same thing that IU and IUM is increased at the end of the names. So once again, these are all those examples which are also written in your books, and these may be different from that. Amine salt. So then
Amines salt.
next,
The reaction of an acid with base produces a salt.
neutralize.
Aromatic
Yes,
amines react with acids in a similar manner.
yes. Once again, we can say that when they are coming to interaction with the salt acids, so they are producing the different type of the salt which is called amine salt. Next one is an amine.
An
Yes, if you can.
amine salt
Yes,
is an organic compound in which the positive ion is a mono, di, or tri-substituted ammonium ion, and the negative ion comes from an acid.
yes. Amine
Amine
salt.
salt can be obtained in crystalline salt by evaporating the water from the acidic solutions in which amine salts are prepared.
Salt are prepared. So they are odorless, white, and crystalline in nature. By evaporating the water from the acidic solution in which amine salt are prepared. So if they are just coming to the solution, the aqueous nature, so just by evaporation, we can get the different type of the salt, amine salts. Next, amine salt are
Amine salts are named using standard nomenclature produced from
procedure.
ionic compound.
Yes,
Procedure from
procedure.
ionic compounds. The name of the positive ion, the substituting ammonium or an medium ion, is given first and followed by a separate word for the name of negative ion.
So these are what we can say the chloride, ethyl, ammonium chloride, dimethyl, ammonium bromide. So this is all depending upon the those salts which are acting with the acid and they are producing the different type of the amine salt. Next,
Yes. An older system for an amine slates still used in the pharmaceutical industry treat amine salts as amine acid complexes rather than as ionic compounds.
dimethylamine hydrochloride, and rather than as dimethylammonium chloride. So this is what we can say the pharmaceutical industries. So different salts are being used in the manufacturing of drugs and different type of the medicines. So definitely they are using them and they are putting their own nomenclature over there in the pharmaceutical industry. Many people, yes.
Many people unknowingly use acids to form amine slates when they put vinegar or lemon juice on fish. Such action converts amines in fish, often smelly compounds, to salts which are odorless. The process of forming amine salts with acids is an easily reversed process. Mama nahi hai.
Treating amine
Treating amine salts with a
strong
strong
base
base, such as the sodium hydroxide, regenerates the parent amine.
online. So once again, we can say that these, when they are acting with those acids, so these salts are making the reaction. So these
Did you see
reactions
what
are reversible in nature. Next,
she did? The opposite nature of the processes of amine salt formation and the regeneration of the amine from its amine salts can be Yes.
Yes.
An
Amine
amine
form.
gains hydrogen ion to produce an amine salt when treated with an acid. An amine salt loses a hydrogen ion to produce an amine when treated with a base. Reprotonation reaction.
So this is what we can say an amine, then an amine salt. So acid pronotation and depronotation, the reverse process is also carried over here. Next, write the. So these are the different type of the exercises you can see from the book also. These are the different type of the reactions and the actions and the chemical equations of amines with the other type of the chemicals which are mostly in organic nature. Then next is heterocyclic amines. Yes, please read this one.
Yes. Is an organic compound in which nitrogen atoms of amine group are part of either an aromatic or non-aromatic ring system. Heterocyclic amine are the most common type of heterocyclic organic compounds. Heterocyclic amines are the first heterocyclic compounds we have encountered that have nitrogen heteroatoms.
Next is selected structure formulas.
Structures of heterocyclic amines that serve as parent molecules for complex amine derivatives.
Uh, Pyridine, pyrrole, coinoyl, pyrimidine, and these are different
Nahi,
the anyl
nahi.
and chlorine. So next one is heterocyclic. Yes, this one.
Hydroxylic amines have strong odor, some agreeable and other disagreeable. The pleasant aroma of many heat-treated food is caused by heterocyclic amines formed during the treatment. The compound responsible for the persuasive odors of popcorn and hot peanut are heterocyclic amines.
Yes. So these are the different type of the heterocyclic amines. Isomerism for
Isomerization for amines.
yes,
Constitutional isomerization in amines can arise from several causes. Different
different
carbon
carbon.
atom arrangements produce isomers as
So this is one of the most process of the organic compounds. So with the amines, this is also there in different way and style. Different positioning of the
positioning of the
nitrogen
nitrogen atom.
on a carbon
Carbon
chain
chains is
is
another
another
cause
cause
for
for isomerism.
isomerization.
So this is all about that the different arrangement of the carbon chain. For secondary and tertiary amines,
Terrestrial
different.
minus different partitioning of carbon atoms along the carbon chain present produces constitutional isomers.
So these are all of the combination of the carbons. Nomenclature for amines. Nomenclature. Naming primary amines.
Nomenclature for the naming primary amines. Select
Yes,
as the parent carbon chain the longest chain to which the nitrogen atom is attached.
name
Name
the
the parent chain from changing the electron ending of the
ending
corresponding alkyne name to amine.
amine.
Number the parent chain from the end near the nitrogen atom. The position of the attachment of the nitrogen atom is indicated by the number in front of the parent chain name.
Parent chain name. One, so this is methane. Two, ethane. Three, propane. Four, butane. And five, pentane. So this is all about the arrangement of the nitrogen. So number one, methane, ethane, propane, four, butane, five, pentane. Methyl, one, butane, amine. Next, in diamines, the final minus E of the carbon chain name is retained for ease pronunciation. 1,4-butane diamine. Once again, methane, ethane, propane, butane, and pentane. हेलो, टाइम पे हो यार, मेरा टाइम था, हाथ में टाइम था।
दुल्ला, देखो दुकान खुली है, बिस्किट ले अपने लिए, चाय बिस्किट खा लो, उठ जाओ। दुकान नहीं देखो,
चाय बिस्किट
कितने रह गए क्लास? बंद है। तो चाय ले ले, ब्रेड खा ले अब साथ। ब्रेड जाओ तेरे पास।
रस भी पड़ी है, रस का जैम पे लगा, जैम जैम ला रहे सिस्टर, तुम ले आओ, लगा देगी। ठंडा बना दे।
बहुत कुछ भी ब्रेड है, सब
खाओ ना,
बहुत कुछ
इधर रस पड़ी होंगे। ये रस पड़े टाइट है, खा के देखेगा तो।